Welcome to another episode. We are continuing solving the problems in section 7.5 in the James Stewart Calculus Really Transcendental 7th edition textbook. We're on number 22, so let's get started right away. We have this integral log x over x squared of 1 plus log x squared dx. Hopefully you can see that this is a substitution. If u is ln x, du is 1 over x dx, which we have over here. So maybe that can simplify something. So let's let u be log x du 1 over x dx. So our integral becomes, this is just u, du over dx, dx over x, that's over here, that's just du. And then the bottom we have square root of 1 plus u squared. Now how do we solve this? You can do this multiple ways. You could probably do a trig sub where u is tangent theta probably. Or if you can see that we can make another substitution, that might be easier. Let's let v be 1 plus u squared. dv would be 2u du. So our integral becomes u du, that is just dv over 2, so half dv over square root of v. Okay? And if it helps you to write this as a negative exponent, like this, would be the same thing. Okay, so now we integrate. It'll be half times v to the half divided by half plus c. Okay, this half and this half would cancel. So we are left with v is 1 plus u squared, where u is log x. So it would be square root of, because to the half power is square root of v, as I said, v was 1 plus u squared. What is u? u is log x plus c. We solved that. Pretty simple, actually. And this actually looks kind of, if we differentiate it quickly, it looks kind of like this. So hopefully you can kind of see that to kind of like quickly check your answer also, that you're at least on the right track. But if we different, well, of course, you can always differentiate to check if it's the same, but sometimes it's a lot of work. Like for example, in this previous problem, if we try to differentiate this, it'll be a lot of work to try to simplify it back to arctan square root x. But for here, it's kind of easy to kind of visualize it. So it just depends on the problem. So just giving you some extra tips to help check your work. Okay, let's move on to 23. What is that? Integral from 0 to 1, 1 plus square root x to the 8th power dx. How do I solve this one? Or how do we solve this one? So let's go down our list, maybe. By parts, I don't think that would be the easiest thing to do, so let's hold off on that, because it is obviously a product of two things. This is one, dx is the other, or 1 dx, but I kind of don't want to do that. Maybe there's an easier way. Now trig integral clearly. Trig sub, I don't see it as something squared plus something squared. Well, actually, technically it is something squared plus something squared, because this is x to 1/4 squared. But that makes things very complicated, actually, so I probably don't want to do that. It's not a rational function, so not partial fraction decomposition. How about substitution? Can we make a substitution here to make it a little easier? Well, it is a composite function, so maybe let's let u be 1 plus square root x. Okay, so how do we find du? We just differentiate, or we can, actually, yeah, let's just differentiate here. It's not too bad. Derivative of 1 is 0. Derivative of square root x is 1 over 2 root x, and then we need a dx. Okay, so let's, actually, yeah. So this is fine. Or we can, maybe it'll be nicer if we, I think this in the previous problem, if we just get x over here, so it will be u minus 1, and then we square it is equal to x. This is the same definition. Okay, I just solved for x. Instead of having u equal something, I want x is equal to something. So this is the same thing. So we differentiate from here, it'll be 2 times u minus 1 du is dx. We need a chain rule. Don't forget the chain rule. Okay? Or the chain rule will be derivative of u minus 1, which is 1. Okay, so this is much nicer. We would get the exact same thing if we move this to the other side. It'll be 2 root x, and how do we get root x? Is u minus 1, which is exactly the same thing, right? So you can do it either way. So let's substitute then. We'll worry about limits afterward. Let's hope I don't forget this time, like I did in a previous problem. This would just be u to the 8th. What is dx? That is 2 times u minus 1 du. And limits of integration, when x is 0, u is 1 plus square root of 0, which is 1. When x is 1, u is 1 plus square root of 1, which is 2. Okay? This is easy. We can, first of all, move the 2 out in front. So we get this. And this we can distribute. The u to the 8th. So it'll be u to the 9th minus u to the 8th. Okay? These are just powers. Very simple. 2 times u to the 10 over 10 minus u to the 9th over 9. We evaluate from 1 to 2. Okay, so that's 2 times 2 to the 10th over 10 minus 2 to the 9th over 9 minus parentheses 1 over 10 minus 1 over 9. Okay, this should be your answer. I'm not going to simplify. Okay, not too bad for this one. Just have to make one substitution to make things a lot easier. Okay, so here the idea was I saw it as a composite function, so maybe let's make the substitution, because that's where substitution comes from. Or one of the big uses is to undo the chain rule type of thing. And chain rule is for composite functions. Okay, next, 24. Integral from 0 to 4. 6z plus 5 over 2z plus 1 dz. How do we solve this one? Well, it's a rational function, so we see that the degrees are the same, so we can do long division to help simplify some things. Possibly. So let's do long division. I know most people don't like to do it, but it's not too bad for this one. Okay, so to get 6z from 2z, what do we multiply by? We multiply by 3. So it'll be minus 3 times this, so it'll be 3z plus 3. Okay, we subtract that. We get, oh sorry, this should be 6z, because I distribute 6z plus 3. Okay, so 6z minus 6z is 0. 5 minus 3 is 2. So we have a remainder of 2. Now we can rewrite integral as, from 0 to 4, the quotient, which is 3, plus the remainder, 2, over the divisor, 2z plus 1 dz. This is simple to integrate. This is 3z plus log 2z plus 1. We evaluate from 0 to 4. Let's double check if I did it in my head correctly. Technically, you could do a substitution here. U is 2z plus 1. Du would be 2dz, right? Which we see is the exact signature. So it'll be log of 2z plus 1. So if we differentiate this, it'll be 1 over 2z plus 1 times 2 by the chain rule, which is what we have here. Good. Okay, so we get 12 minus log of 9 minus parentheses 0 plus 0. So actually 0. So it'll be 12 minus log 9, plus log 9, sorry. Okay? That should be the answer. Next, cruising along, integral 3x squared minus 2 over x squared minus 2x minus 8. So again, it's a rational function. Degree at the top and the bottom are the same. Like here, let's do long division. Okay, and outside is this. Okay, how do we get from x squared to 3x squared? We multiply by 3 minus 3x squared minus 6x minus 24. We subtract these two. We get plus 6x. and then minus 2 plus 24. So that's plus 22. Okay? And that's it for here. So we can rewrite this as 3 plus the remainder, 6x plus 22. Is it 6, or did I write the problem wrong? It should be 6. Okay, over x squared minus 2x minus 8 by dx. Okay, so this term is easy to integrate. How about here? We need to do partial fraction decomposition most likely. Okay, so let's do it on the side over here. So it would be 6x plus 22 over, how do we factor the bottom? It will be x minus 4, x plus 2. It's equal to a over x minus 4 plus b over x plus 2. Multiply both sides by the denominator. 6x plus 22 is a times x plus 2 plus b times x minus 4. You plug in easy numbers like x is negative 2. What do we get? We get minus 12 plus 22, which is 10, is equal to, this would go away because minus 2 plus 2 is 0. We get minus 6b. So b is minus 5 over 3. Plug in x is 4. What do we get? We get 24 plus 22, which is 46, is equal to 6a. A is equal to 46 over 6, which we can reduce. Let's reduce by 2 first. 23 over 3. And actually, that's it. Is this correct? I'm not sure. Let me quickly double check Wolfram Alpha to see if I'm on the right track. I made some math error somewhere. It's looking good to me. Okay, so we did our partial fraction decomposition. So let's write this one more time. 3 plus a is 23 over 3. 23 over 3 times 1 over x minus 4. B was negative 5/3 minus 5 over 3 times 1 over x plus 2. All by dx. Now we can easily integrate. This is just 3x. This is 23 over 3 log of x minus 4 minus 5 over 3 log of x plus 2 plus c. Okay, let's move on to 26. And then I'll call it parts. Okay, 26 looks like another rational function. Integral 3x squared minus 2 over x cubed minus 2x minus 8 dx. So there's a cube there, so are we able to do partial fraction decomposition? Actually, we don't even have to do that. Hopefully you can see there's a very clear substitution. It's actually a quite easy problem. Let's let u be x cubed minus 2x minus 8. du would be 3x squared minus 2 dx. And we have that right there. So even if it's a rational function, you should always check if you could do a quick substitution like this. And then it'll make things a lot easier versus you going to do the partial fraction decomposition. Okay? So here, we just have du over u. So we get log of absolute value u plus c. We back substitute. That's our answer. This one was very simple, actually. Okay? So it looks very close to this problem we had over here, except it's a cubed. But when it's a cubed, it's actually much easier. So yeah, just always look for substitutions when you can, because usually it makes things a lot easier. All right, I'll call it a part here. Please like this video, as always, if you found it helpful. And please subscribe also, if you haven't already. And you'll get notified also when I solve the next few problems in the next video. So hopefully I'll see you in that video.